Hello everybody, I'm Camila Maia. I'm super glad to be here presenting at DjangoCon US, and today I'm going to talk about Factory Boy and some best practices when using it. This presentation you can find at speakerdeck.com/cmaiacd. So let's get started. Who am I? So I'm a backend developer at SoundCloud. I'm a Brazilian living in Berlin, Germany. I have a Bachelor of Computer Information System. I'm coding since 2010, so a long time ago, more than 10 years of experience. I have most experience with Python and Ruby programming languages. I love to work with open source, contributing with it, using it, and also I love the communities, like tech communities in general. I love to help in attending to conference. I have helped, for example, to organize some of these conferences, PyJamas, EuroPython 2020, Python Brazil 2020, and others. So yeah, hi. Also, I'm creator of Scan API. That's an open source library that helps you to create integration tests, like automated integration tests, and also auto-generate documentation for REST API. So it's a pretty nice project that I am helping to maintain since 2019. And because of these contributions and other contributions, my GitHub profile was the first one to be accepted for the GitHub sponsors program in Brazil. And the first sponsorship that I received was from New Relic, a pretty nice sponsorship as I started. So got pretty proud about this achievement. But anyways, let's stop bragging and let's start with the presentation. I'm going to talk about Factory Boy. This is not an introductory, this is like not an intro talk. I will talk about more about best practices, but I will just give you an overview of what is it if you don't have, if you didn't work with it before. But as I said, I will probably assume that a lot of concepts here I already know. So basically, Factory Boy, it's a fixture replacement. So we mostly stop using fixture and start using factors instead. It's based on Factory Bot, that is a Ruby library. First, before being called Factory Bot, it was called Factory Grow, and then maybe that's why we have like a Factory Boy in Python. And the first time that I used was the Factory Boy. The Factory Bot, and I thought it was pretty nice when I saw that there was like a corresponding library, the same idea in library for Python, so quite nice. The first version for Factory Boy was only working with Django, but nowadays it's framework independent, so it works with Flask, Django, and wherever, and also work with unit tests, PyTest, so it's quite flexible. Basically here we are going to talk about the advantages of using Factory Boy for complex objects, because like if you don't have like a really complex database, you don't have complex models with complex relationships, the fixtures will work fine, and probably you won't need all these best practices that I'm going to talk about in this presentation. This presentation is more focused when you have like huge data models, complex relationships, complex objects. So in this scenario, why fixtures are not that good? Because they are static, they are hard to maintain, while factories, they are super easy to use, they are customizable, you can use the specific fields that you want for the specific test you want to create. So fixtures, you need to create an exhaustive test setup with every possible combination of corner cases. So you have to handle all the corner cases in the fixture like separately, while with factories you can customize your objects for the current test, so you can declare only the specific test attributes that you want, so you can use specific things that you want. Another really good thing about using Factory Boy for me is like it comes with a lot of different tools that help you in the creation of the test. For example, you have sequence. Let's say that you have a model, user model, and this user has email, But then if you hard-coded the email, like saying user@gmail.com, the next time that you are going to create a new user, and if it is like a unique field, you're going to have a problem because it's saying that the two users have the same email. So a sequence would be like a pretty good feature that you could use. So saying that programmatically you will increment one number by the end of the email. So let's say that the user 1 will have the email user1 at gmail.com, then user2 at gmail.com. So it will incrementally change this sequence, so it will change the email. This is like one example, but we have a lot of different tools like Faker to create fake address, fake questions, fake names. You can use a lot of fake stuff here, mainly to avoid like using hard-coded, and you can like check more different edge cases for your tests. You have fuzzy attributes, lazy functions, have a lot of different tools. I'm just listing here so you can check around, but it's really, really powerful, this set of tools that comes with Factory Boy. Okay, so to start talking about the best practice, first we need to go one step back and talk about this demo app, this demo application. This is just like a super simple application that I'm going to show you here. And based on this application, we are going to show some examples, bad and good examples of how to do it following this best practice. Of course, I was talking before that this best practice in the presentation focus on complex objects and complex relationships. And the ones that I'm going to show here in the demo application, they are not complex, they are super simple, but they need to be simple so I can explain better here in the presentation. But the idea is like to extend the same principles, the same practice for complex objects and complex relationships. So let's see this demo application. Basically, it's a web app, and the first main page, the index page, actually the /post page lists a sequence of polls. Basically, polls are like questions that will have like options for a person that can vote, and we have some specific things here in this page. First thing is that every poll that is new, this means that it was created in the last 24 hours, we will present this label here, new. Also, all the premium questions, like premium polls, we'll have this star here in the front. Besides, a question or poll can have an author. So, can have or not. So, if there is an author, it will be appended to the end of the poll. So here, for example, it's saying Coke or Pepsi is the question, and this question was created by Camila. And if you notice here, we have different languages. So if there is this is like the final thing here that we need to take notice of, is that if the question is in English, then we are going to append by to the name of the author. So we are going to say Coke or Pepsi by Camila. But if the question is in Portuguese, we're going to translate this by preposition to the Portuguese corresponding one, that is por. So we have the question in Portuguese, and then it's saying por João Silva. So this is like the name of the author. Basically, this is all the business logic that we have. And this is all the logic that we have for this application. Let's see more in details. Also, if you click on one of these polls, it redirects you to the vote section, to the vote page. That's the detail of the poll. So you can choose here if it's Coke or Pepsi that you want to vote. If you click vote, you are redirected to the results page that says the results of this current poll. And you can vote again, or you can see the results and so forth. So here is the relationship, the models and the relationship between them. First, we have the model poll, which contains the date, published date. That's a datetime field. We have the premium Boolean, so it's saying that a poll can be premium or not, true or false. Also, we have the author, that is a char field, so it's an open text to put the name of the author. And the poll has a relationship one-to-one to the question model. A question has a text that is a char field, an open char field, and a language that is a char field, but it contains like choices that in this case could be English or Portuguese. And the last model that we have here is choice, and the choice is related to questions. So one choice can have one or any questions, and a choice has mainly the fields choice text, that is the option of the choice, and also the number of the votes, so an integer that sums the number of the votes in that choice. So this is like the relationship between the models. Nice. Also, how can we add and change a poll, add questions? So this is done by via Django admin. So you have Django admin where you can add a poll, and then you can add the information about it, the published date, the question, and also you can add directly the choices for that question with the votes. So you can start with all 0, or you can like start with any different votes you want. Nice. This is like an overview of the admin, where you can see basically the question text, the language, how it's formatted, the name of the poll, and the published date. Now talking about code, let's see the models, the code of the models. So the first one is poll. As I already presented, we have one-to-one relationship with questions. We have the published date, premium, and author fields. And we also have a string method, the underscore, the understring, that says, that basically is responsible to format the text of the poll. So it grabs the question text, and then puts the star or change to by and pour if there is an author, and also append the name of the author. So basically the understring method is responsible to format this. There is also one property of the model poll, the poll model that was published recently, that basically check if the published date was in the last 24 hours and not in the last day. Awesome. The question model is, as I already described, it has the question text, has the language, and also has two properties. One is to check if it's in English, this returns a Boolean, or it's in Portuguese question, and the string just returns the question text. And we have the choice model here that basically contains a foreign key to the question, also has the question text and the votes. And this is like a simple model. Awesome. So let's start talking about the best practices. Why we started to work with this best practice, and what happened that we start thinking about to came with this list of practices. So the scenario was that I worked with a huge Django monolith, more than 3 years with it. And in this Django monolith, we were using Factory Boy, and in this Django monolith, besides of its size that was huge, it also has like really complex relationships. So to get a sense of how big this monolith was, it had more than 230 tables, more than 2,200 relevant files, and more than 75k relevant lines of code. So it was huge, and not only huge, but also super complex. The business logic was super complex, and to work with it was pretty hard. So basically, we starting working with this monolith, and we starting to notice that bad factories are like viruses. So basically, when you start working with factories and they are not really well designed, you can get super tired factors that they are not flexible, and you cannot use in the way that you would like to. So they are not customizable as you would like to. So also, if you have like bad factories, and you don't understand how the relationship with the factories are, if they are not like really mapping from the database, what can happen is that a lot of implicit errors are starting occurring. So you're testing, you take a look at your test and everything seems fine, but then you realize that the problem is like in the factory. So when you were creating the factory, when the declaration of the factory, the problem is like there. So you can start facing a lot of implicit errors. Also, if you create a factory that's not well designed, and this actually happened a lot. Like we had one factory that was not well designed, and then we couldn't change it because if you tried to change it, it would break a lot of stuff. So what we did was we started using the factory, but then changing everything that we need every time in a test. So we fixed this factory every time in the test suite. So what happens is that everyone is starting to copy and paste the solution from one place to another, handling like starting having a lot of really bad code on it. So a poor design factory might affect many tests. And the tests, like, this is like the thing that we call it as factory-oriented testing. Like we started to think of how we are going to make this test pass in a way of the business logic, but we started to think how we are going to change the test to make it pass using this factory that's not well designed. So we started to change everything in the test to accommodate that bad designed factory. So this was like factory-oriented testing and not the way around it should be. So what happens is that the developer is starting to bump into the same issue again, and copy and pasting, without being able to change the factory and also using it in trying to fix in every single place. So it was hack after hack after hack after hack. So what we started to do is like, okay, we have to refactor this, we have to improve this. So let's get this really big factory here, that's really important factory here. Let's start to like recreate it. Let's create it in the way that we think it should. Like afterwards, we have like now some experience, and now we know how is the best way to create it. So let's put everything on trash and start like recreating only one single factory. So we refactor everything from that factory. What happened is that from a test suite that we have more than 1,000 tests, more than 12,000 tests. When we changed that factory to be the way that we wanted, more than 1,500 tests were broken. So basically the problem is that they're really like virals. Once you created one not well-designed factory and starting to use it everywhere, it's really hard to maintain it and to fix it. And it generates a lot of duplication. So, okay, based on that, we start to figure out, we understand that we need best practices, and we start like creating this list of best practices. And here the idea is to pass through everything that we learn, and I hope it helps. So the first one is that factories should represent their models. This means that everything that we expect that it has in the database should be reflected, should be mapped to the factory in the same way. So let's see an example. Here we have the poll factory and we have the question factory. If we see here in this factory, we are creating a related factory poll inside the question factory. So we are saying that the relationship here is being mapped inside the question factory. If we see here in the models, in the question model, there is no mention anywhere of poll. So here in the question factory, we are mentioning and we are creating the relationship with poll. But in the other hand, in the question, in the database itself, doesn't have any mention. If we see the relationship is in the question, is in the poll. So poll points to question. So the best way to do this, like that we believe, is that changing. So now the relationship reflects what is in the database. So basically the poll factory now points to the question and not the other way around. This also avoids having implicit errors. Because if you are already used with the database, you already know the relationships, you already know how things works in the database. When you see a factory, for example, you are going to use a factory and you are not seeing like how it's written, like how it's like initialized. You only see like Poll factory. You already would imagine that there is a relationship with question. You don't need to go and to see the class itself because you already imagine it. So the idea would be like you would expect that there is this relationship, and then if there isn't, or if the relationship is in another way around, probably this would generate implicit errors, like errors that you wouldn't expect. The second best practice is do not rely on defaults for factory. So basically, if the default value changed, so if you are like relying on the default value, and these values change, all the tests that depend on it will break. So basically, the idea here is that you need to set up your tests to have everything to pass and not relying on the factory creation itself. So this mainly says that we want to explicitly say what we are going to use in our test and not get the attributes defined by default implicitly. So we want to be like implicit here. So implicit is better than implicit. What would be in the terms of an example? Here we have the poll factory, and as you can see here, we are setting in the question factory the default text question, the default value for the question text, that is WhatsApp. So when we are testing the poll now, we are asserting that the poll text that comes from the question is WhatsApp. But if someone comes and changes this default value to something else, this test will start breaking. So we are not defining everything that we need in our test. What would be the best way to do this? So we have the poll factory, and in the question factory, instead of hard code the value like WhatsApp, we could use faker here, for example. So it would generate random sentences for you, and then you cannot rely on this. And then on the test, you would explicitly say everything that you want from your factory. So in this case, we want a question, but it's not we want a factory here, for example, but we want a poll here, for example, but we want a specific one, right? So we want one that is not premium, with non-author, and with a question text explicitly saying. So here we are saying explicitly like it's a Pepsi or Coke. And then we are going to assert it. We assert with this value. So if someone here changes, or like the faker changes, it will not break our test because we are explicitly saying everything that we want in this test. Okay, cool. Let's go to the third best practice. Factors should contain only the required data. So basically the idea here is if the field is nullable, what this means that in the declaration of in the database it can be null, so null equals true, the attribute should be under a trait and not as a default value. So let's see an example here. We have poll factory here and question factory again, and here we are saying that for the poll factory the author is João. If we come here, we see that the author in the model can be null. So we are here saying that explicitly for every poll factor that we create, if you don't say anything, implicitly we are going to have an author João already. Okay, and also here the question factory. So if you see the question factory here, we have language, but the default is English. And here we are setting the default as Portuguese. So this means that everyone that creates, every time that we create a question factory, it will come implicitly the language as Portuguese Brazilian, a Brazilian Portuguese, and not the English one that we would expect reading the model, like knowing the model. So what would be the best way to do this? The best way to do this is, like, first of all, putting the author under a trait. So since we can have polls without author, let's make it if you want this outer, you need to be explicit. So if you say nothing, you will not receive an outer. But if you want to have an outer, you need to pass with outer equals true. And then it will come an outer with a random generated figure name. So in this way, you are being explicit and you are following the same structure of the database. And here for the question factory, we just don't say anything about the language, because by default it will come already with English. Okay, so the idea is that for the outer thing, now you can use poll factor with outer equal true. And this is especially important because if in the database we can have, there is the possibility of having an outer equal known, and you explicitly say that outer will always have a value. When are you going to remember to test outer equals known? It's hard. So we should not assume there is an outer when in the database actually allows to not have it. So the idea here is to be explicit. If you want an outer, you have to pass true. If you don't want an outer, then you don't say anything, because this is already what the database would do. Nice. Let's go to the fourth best practice. This one is more related with performance. So basically, it's to use build over create. Let's first see the difference between them. So if you run myFactory.build, it will create a local object, but in memory. If you run myFactory.create, it will create a local object, but it will also store it in the database. So when you use create, it really hits the database. And because of that, of course, build will be way faster comparing with create. Actually, let's see an example here. So let's say an example of using create that is not the best scenario for performance. So if you use create, notice that you have to use the notation Django DB, because then you need to explicitly say that you need to use the database. Otherwise, this test will fail if you don't use the notation. So to fix it, to make it faster, and also to be more like unit tests, because unit tests wouldn't hit the database, as at least we would expect that. So to fix it, we would use build instead of create, and then we don't need the notation. And actually, when we notice that, because as you can imagine, we have this monolith with more than 10,000 tests and 12,000 tests, and it was super slow to run the test. And then once we figure out that the build was faster than create, it was really a game changing. Just to show you an example, we did one test with one file. So in this file, we only used the create strategy. So 14 tests passed in 3.26 seconds. It took more than 3 seconds to run the 14 tests. And using the same test file, but just changing the strategy. So starting using build instead of create, the test started passing in less than 2 seconds. So the thing is, it was really, really way faster. And this is only for 14 tests. Imagine for more than 10,000 tests, how fast it should be, right? So of course, there are some times that you need to really use the create, you really need to hit the database and so on. So this is just an advice that's saying, if you want things to be faster and you really want to be doing unit tests and not integration tests and so on, use build instead. So now we are in the fifth best practice, and this helped a lot because it took us a while to understand this relation, but once we figured out, it was super nice because we could map the database exactly as we want in the factories. So basically the rule says that if the foreign key is in the table, you are going to express this relationship using a subfactor. If the foreign key is in the other table, it's not there, so we are going to express this relationship with related factor plus trait. Why this happens? Basically because of the difference between subfactory and related factory. Subfactory, it builds and creates the subfactory during the process of creating the main factory. So the main factory and the subfactory, they are created at the same time. While on the other hand, related factory creates the related factory after creating the main factory. So first you create the main factory, and once it's already finished, it creates the related factory. So let's see how we should do that. So we have here the choice factory and the question factory. Okay, so if you see here the choice factory, we do have the relationship explicitly saying here in the model. So choice has a foreign key to a question. So when we have this relationship declared, like explicitly saying here, then we are going to use the subfactory. So if you see here, we have the subfactory being declared here. Cool. And on the other hand, if you go here and see the question does not mention anything about choice. So in this way, we are going to use related factory with a trait. Why? First, because choice in this first scenario, choice depends on question. So we need to have the question and then and have the choice at the same point. But a question doesn't depend on choice. We can have actually questions without choice. So we cannot explicitly say that we always have choice. So that's for this reason we are going to use a trait, because then we can create questions without choices. And then if we want, we use the trait with choice. And then using this trait, because we are using a related factory, what will happen is that factory boy will create first the question factory and then the related factory, that is the choices. So basically, this is the way that you would create this relationship. And in this way, you can map exactly what is in the database. The sixth best practice is to use fixtures. So I said that factory boy is like a fixture replacement. It is, but in this case, we can still there are some cases that we can still use fixture. Like if you have like really, really simple things to wrap, or in this scenario specific, we can use fixture to wrap factories to avoid duplication. So this is a really nice use of fixture combined with factories. So let's see this example here. We have two tests in the same file, but where they declared, they create this factor, this poll factor. So we have the same poll being declared twice. And if you see, they are using the same attributes. So it's the same thing, duplicated code that we could avoid using a fixture here. So we create a fixture, give the name, explicit name of English no premium with outer poll. So here it's like this fixture is returning this factory, and then we can reuse. But this brings us to the next best practice, that we can use fixtures, we can use factories as we were doing so far, but we should not, and we should try to avoid sharing these factories of our fixtures both among different files. Why? Because if you start sharing these factors and fixtures, many tests depending on them. So if you want to change one factor or one fixture, you need to fix a lot of different tests in different files. That makes it even harder. Also, what happens when you start sharing is that it tends to inflate the factor or the fixture, because in one scenario you have these criteria and then you add the attributes that you want, but then for another file, another test, you need more different fields, you need more traits, you need a lot of more things, and then you start putting everything in the same fixture or the same factor because they are shared. So it starts getting really big and it's hard to maintain, it's hard to read. It's awful. We had this problem in the monolith where we have like a fixture file and one really, really huge fixture with a lot of edge cases, a lot of different things, and be used in a lot of places. So to change it was pretty hard. And yeah, so if you change one, you break a lot of stuff. And this also brings the idea of when the things are too tight, you starting just changing everything on your test, fixing the factory, fixing the fixture in a way to make it pass. And you are not more thinking about your test. You are now thinking way more in the factory, in the fixture. You are just trying to pass it. So it's not a good scenario. So that's why we should try to avoid sharing fixture and factories in general. So basically, all this code, this best practice, and are in the GitHub repository under my profile. So it's Camila Maia /Factory Boy best practice. You can see all the best practice and also the demo app. And the demo app also has like folders with good examples and bad examples, so you can check and see the code running. And just as a review or recap, the best practices are factories should represent their model. I think this is like the most important, because if you really follow this one, you almost have all the others. The second is do not rely on the defaults for factories, because they can change and then they will break a lot of different tests. The third one is factories should contain only the required data to avoid implicit errors. The fourth one is performance. So build over create. Build is way faster, and also it doesn't hit the database, so you are testing on like only the unit you want. Fifth one is about the relationship. So if the foreign key is in the table, use a subfactory. If the foreign key is not there, is in the other tables, if the relationship is not there, then use a related factory under a trait. The sixth one is avoiding sharing factory or fixtures among different files, because this makes harder to maintain, makes harder to use the fixtures, and it's hard to read also. So, and the seventh one is use fixtures to wrap factories to avoid duplications. And you can use fixture, but it's a good way, especially to avoid duplications or to avoid factories. So these are the 7 best practices that we try to map, and I'm trying to pass here. I hope this helps. I hope this helps you in your day-to-day work. And thank you very much. The links are here. So this is the documentation from Factory Boy. You can check it, it's the official one. They also have the common recipes that basically are some tips of how to use the factories. There are some best practices also there. So reading this can also help you solving some problems. And if you want to check the code itself of the library, here is the repository. Thank you very much. It's a pleasure to be here at DjangoCon US. If you want, and please let's keep in touch. My website is cmayacd.com. My handle on Twitter, there is mostly where I'm more online. So if you want to get in touch, send me a DM there. And also my GitHub is Camila Maia. Thank you very much. It was a pleasure. See you. Bye.